So this is complex numbers. The P stands for polar form, or polar form of a complex number. R stands for rectangular form. Polar form is always r theta, so they're gonna give you a number. R stands for the radius, like when you got a circle with a radius. That's what r is, and theta stands for the angle, like what angle that point is. And you know what x and y are. This is just regular rectangular when you like plotting a point. So we gonna go from one to the other. So we basically gonna go from P to R and R to P. So from P to R, that means you got R theta and you trying to change it to XY. To do that, you need the formula. So the formula is for X. If you're going from P to R, that means you already got R theta. You're trying to go to XY. So to get X is going to be R cosine theta. Whatever R is and whatever theta is, you plug it in this formula and it'll give you what X is. And to get Y, it's going to be R sine theta. Same thing, except you're just using sine instead of cosine. So that's how you get to XY, which is not that difficult. But when you go from R to P, this is rectangular to polar, so you already got XY here. You trying to get R theta, so you trying to go in this direction. So to get R, and you already got XY, it's going to be x squared plus y squared, and then you take the square root of that. That's going to be your R, your radius. And then, yeah, one more second. And then to get theta, you got to do the inverse tangent of y over x. Y'all just got through doing inverse sine, inverse tangent to get the angle. So if you got x, y, and you don't have an angle, you got to do inverse tangent of y over x. And y always go up top. X always go on the bottom for this one. So everybody good with that? And then the polar form, this is something different. You're going to see it, is you need an R, which you get from over here. And you need a theta, which you get from over here too. So if they tell you to put a complex number in polar form, you need to get the R and the theta, and once you get it, you just plug it in here. You don't do no calculation, you just plug it in and then you already got the polar form of it. So I stands for really complex number. That's what I, imaginary. It means imaginary in a complex field. You said repeat it? Yeah, the I stands for imaginary. That's how you know you got a complex number, when you got an I part to it. So an example, let's say we got let's say they give us 4,90. And I'm gonna need somebody with a calculator to help me since I don't have one. So this is given to us not in rectangular, but in polar. You know it's in polar because the second one is a degree. That's a theta. If it was just a regular number, then this would be in rectangular form. But since it's not, it's in polar. So if it's in polar, then they want us to convert it to rectangular. And on the assignment, it's going to tell you, convert this to rectangular. That means that you have polar. And so the 4 is the R, and the 90 is the theta. And so you're trying to change this to an XY. So remember the formulas. X is going to be it's going to be R cosine theta. And you have R and you have theta, so it's going to be 4 cosine of 90. Yeah. And so plug that in the calculator. Make sure it's in degree mode before you do it. And somebody tell me what 4 cosine 90 comes out to be. Come out to be 0? So that means X is 0. To get Y, it's the other formula. It's going to be R sine theta. Which you already got R and you already got theta, so that's going to be 4 sine of 90. And you plug that in the calculator. Comes out to 4. So what it's telling you is that 4 cosine 90 in polar is going to convert to 0, 4 in rectangular. And this is extra. I'm going to just show y'all this. Just so y'all can see what's going on. You know, if you got, say for instance, you got the XY graph. 0, 4, it goes up 4 From 0 it goes up to 4 and it stops right there, right? Okay, in polar form it'd be 4 comma 90. So 90 degrees is from here all the way to the other line, right? And if you go a radius of 4, it's going to be right at that point. Y'all see that? So if a radius is 4 and it go 90 degrees, it go from this line all the way to that line, and then it's got a length of 4. So it's up 4 points. And it's the same thing as saying 0 comma 4, which gives you straight at the same point. Okay. So let's say, okay, a 90 degrees is pretty much an L shape, right? From here, this is 90 degrees. And this is saying, okay, if it's 90 degrees, then it's going to be this line right here. And it's saying the radius of this line is 4. The length of it is 4. So this line got a length of 4. This line has the length of this line is 4. And let's say if this was an XY chart. If it was an XY chart and you were plotting 0 comma 4, then that means 0 means you don't go nowhere left and right, but you go up 4. So you're still going to be at the same end point right there. If it was starting at 0, going 90 degrees at a length of 4, you're at the end point. And if you plot 0 comma 4, you're still at the end point. So it's two different grids on the same axis. So let's say you had 230. So a 2 and 30 would be right here. 30 degrees, you can say that this is about 30 degrees right here. And let's say that it had a length of 4, so it'd be a point right here. And if you was converting 2 and 30 degrees to a rectangular, it looked like it might plot at 2 comma. If you say that this is a 3 and this is 2, then it'll plot at this point right here, which is 2 comma 3. So if you had 2 comma 30, then it should plot at 2 comma 3. It should be at that same point. This is extra though. Y'all not drawing no graphs. Y'all just doing the calculation. Yeah, I'm just trying to put it all in picture form, so you can see what's going on. So that's from polar to rectangular. So let's say if we got an example that's rectangular. So that's going to look like, let's say they give us 2 comma negative 2 square root of 3. And since these are two regular numbers, and that means they're x and y. It's not r and theta because they didn't give you a degree. So since they gave us x and y, we got to convert it to a r theta. Negative 2 square root of 3, yeah. So we got to convert this to a r theta. You know the formulas. So r, just to write it down, it's going to be x squared plus y squared. And all of that is under the square root. So you know what x is. X is 2. So you're going to have 2 squared. But it's going to be plus. You got to put this one in parentheses. It's going to be a negative 2 square root of 3 squared. And that's inside all under the square root. The 2 squared is simple. You're going to get 4 out of that. But the other one, the way you do that, if you don't want, you can do it with a calculator, but without the calculator, if you square the negative 2, what would you get? Well, negative 2 times negative 2. That'll give you positive 4. Okay? Square root of 3 times square root of 3 is what? What would you get if you multiply square root of 3 times another square root of 3? You get 3. So you're going to have 4 and then you're going to have a 3. And what you do is you multiply them two together. 4 times 3. And that'll give you what? So that negative 2 square root of 3 squared squares out to give you 12. Everybody got that? Okay. Let me put another one up here. Let's say I got 3. Let's say I got 3 square root of 5, and I'm squaring that. You got to square the 3 first. When you square the 3, what you going to get? 9. So that's 9. Then you got to take square root of 5 times another square root of 5. that's going to give you just 5. Whenever you multiply a square root of something times itself, you just get what's under it. So it's just going to be 5.
The 2 cancel out the square root.
Yeah. And once you got the 9 and the 5, then you multiply them two together. And that give you 45. So 3 square roots of 5 squared is going to give you 45. And so up here we got negative 2 square root of 3 squared, so that gives us 12. So when we add this inside up, we're going to have square root of what? 16, which comes out to what? Square root of 16? 4. So that's your R. So you got R. So now all we need to find is what? What's the other missing part? You got X, Y, and that's going to convert to R, comma what? And draw it right here so y'all can see it. Theta. And the formula for that is inverse tangent of Y over X. And you already know what Y is and you already know what X is. So it's going to be inverse tangent of, what's Y? A negative 2 square root of 3 over X, which is just 2. Instead of putting all, you can put all that in the calculator just like you see it, but you can also simplify it before you put in there. Because what cancels out when you look over here? The 2's. So when the 2's go away, you're going to have inverse tangent of what? Of just negative square root of 3. That's what you put in your calculator. And that's going to give you a degree. The 2's, because when you have, like, let's say you got, it don't matter. Yeah, if you see the same thing on the top and bottom, they just cross each other out. The negative sign is still going to be there. The 2's just went away. So when you do inverse tangent, negative square root of 3, what does that give you?
Inverse tangent. Square root negative. Square root of 3, you said?
Mm-hmm.
Another second function, square root of 3.
Negative 60. So that's negative 60 degrees.
How would you plug that in?
You got to hit the second button, inverse, second tangent,
Second part, okay, tangent.
open the parentheses, and put,
Parentheses.
you got to hit, to get the square root, you got to hit second again. So you got negative second square root. I think it's the x squared button. And then hit 3 and hit enter. And the degree comes out to negative 60.
I'll figure it out. Okay. Here you go.
Oh no. So another